A vehicle travels 4 km with speed of 3 km per hour and another 4 km with speed of 5 km per hour, then what is its average speed? So let us first write down that what are the data given. So we have the vehicle first travel 4 km with speed of 3 km per hour. So let's write this as S1 equal 4 km and V1 equal 3 km per hour. So with the speed of V1, the vehicle travels S1 distance, okay? And then with the speed of, let's say, V2, 5 km per hour, the vehicle travels S2 distance, which is again 4 km. So we have to determine its average speed. So what is the definitions of average speed, by the way? The definition is total distance traveled by total time taken. So we know the total distance traveled, right? Total distance travel is 4 plus 4, yes, 4 plus 4, we have to evaluate the total time it took to travel this distance. So from here we obtain T1 equal S1 by V1, which is 4 by 3, and from here we will obtain T2, let's say S2 by V2, which is 4 by 5, yeah. So substituting the value here, 4 by 3 plus 4 by 5, this gives 2 by 1 by 3 plus 1 by 5. I simply cancel out 4 from numerator and denominator and simplifying what we will obtain here. It is 2 by 5 plus 3 by 15, which is 2 times 15 by 8. This is 15 by 4. So the average speed is 15 by 4 km per hour. Okay. In this case, the coordinates of a particle moving in a xy plane are given by these two equations. We have to find the motion of the particle. We have to determine the motion of the particle. Okay. So it's given x equal 2 plus 4t and y equal 3t plus 8t square. So the particle is moving following this equation, where t is a time, okay, or any parameter. T is any parameter, okay, maybe time or something like this, but t is a parameter. So we have to determine what kind of motion is this. So let's evaluate x dot, that is dx dt. This gives velocity along x direction. It is 4, yeah, and y dot, that is dy dt, it is 3 plus 16t. I am just differentiating, okay. I hope you guys know calculus, right? So we observe that the velocity, how to obtain velocity? Velocity is x dot square plus y dot square, right? It is the formula for velocity in two-dimensional motion in this case. So we observe that in this case the velocity is not uniform, right? Because y dot is variable, y dot is depending upon the parameter, correct? Y dot is depending upon the parameter. X dot is constant, but y dot is not constant, it is depending upon the parameter. So velocity is not uniform, okay? So it is a non-uniform motion, there is no question about that, but what kind of, whether it is non-uniformly accelerated or it is uniformly accelerated. So here the question is about, here the options are about uniform accelerations or not, okay. But in order to evaluate acceleration, we need x double dot and y double dot. Yes. So what is x double dot? X double dot is d2x dt2, that is ddt of dx dt. This is 0, right? Because dx dt is 4 and ddt of 4 is 0. 4 is constant. And what is y double dot? Similarly, y double dot is again d2y dt2, which is ddt of dy dt, and it is basically, so we have 3 plus 16t ddt of 3 plus 16t, which is 16. Okay. So we have our x double dot, that is acceleration along x direction is 0, but acceleration along y direction is 16. Okay, which is constant. Okay. According to the formula, our acceleration is x double dot square plus y double dot square. This is 0 plus 16 square equals 16. So acceleration is constant. Okay, so it is uniform acceleration. It is not non-uniform acceleration. Okay, it is uniformly acceleration. So BCD along BC, A cannot be the answer. So either the correct answer is B, or the correct answer is C, or the correct answer is D. Now we have to determine that which one among this is the correct one. Okay? Well, C is also not correct because it is not uniform motion, as we have obtained in here. Here we have obtained that the motion is not uniform. Okay. So B, A ruled out, C is also ruled out. Left B and D. So either of B or D can be the correct option. That we have to determine that which one is the correct. Okay. A is ruled out, C is ruled out. So let's now focus on B and D. Well, it is uniform acceleration. Acceleration is constant, so it is uniform acceleration. Now, in order to determine the path, how we will proceed? Well, observe that we have our y dot equal 3 plus 16t and our x dot equal 4. So therefore, dy dx equal y dot by x dot. Yes, dy dx is y dot by x dot, right? This is 3 plus 16t by 4. If you simplify this, this is basically 3 by 4 plus 4t. So we obtain our dy dx equals 3 plus 4t, and we have a parametric term in the right hand side, but we do not have any parametric term in our left hand side, so we have to evaluate t, and this is possible from this one. Okay, see, 4t is basically x minus 2, right? So it is 3 plus x minus 2, which is basically 1 plus x. Okay. Yes, 4t equals x minus 2. So now what we obtain is, we obtain our dy dx. I have very small space here, so I will try to finish it here. Equal 1 plus x. Now, if we take integration to both sides, I am just skipping some steps because I have very small space here. If you have any doubts, you just let me know in the comment section. Okay. So from here we can obtain our y equal integral of 1 plus x dx plus c, which is basically 1 plus x whole square by 2 plus c. Okay, so this is our y, which is clearly the equation of a parabola, right? Yes, because it is in the form of this y equal ax square plus bx plus c. Yes, it is in this form, and we know this form represents a parabola. Okay, so D is also ruled out, and hence B is the correct choice. Okay, a boy pushes a box of mass 2 kg with the force 20 I cap plus 10 j cap Newton on a frictionless surface. If the box was initially raised, then We have to find the displacement along x-axis after 10 seconds. So the equation of force, the expression of force is given something like this. Force is a vector, and we also know from Newton's third law that force equal mass times acceleration, right? That is m acceleration. Here the acceleration will be something like this. It is x double dot I cap plus y double dot j cap, right? So this is the acceleration. The definition of acceleration we know in vector form: a vector equal x double dot I cap plus y double dot j cap. Yes, and this is given as this one. Okay. So now if we compare from both sides, we obtain m x double dot and my double dot equals 10. You simply compare the component along x-axis, that is this one to this one, and along y-axis, that is this one to this one. So we have x double dot, our m equals 2, so we have our x double dot equal 20 by 2, that is 10, and y double dot equal 10 by 2, that is 5. So since we are interested along x-axis, so I will not take account y double dot anymore. So I will work with x double dot from onwards. So x double dot equal 10. If we integrate this x dot, integrating with respect to, let me show you the calculation here. So x double dot integrating with respect to t. Okay, this is 10 dt plus c. This implies x dot equal 10t plus c. Now it is given that the box was initially at rest. So at t equals 0, x dot equals 0, right? Because let me show you this one as well. X dot equal, v vector equal velocity in a plane is this, y dot j cap. So x dot equals 0. So this gives c equals 0. Okay, that is x dot equal 10t. Okay, now x dot equal 10t. This implies, similarly again integrating with respect to t, this is 10t dt plus c. Again let's say this is c1, and this implies x equal 10 t square by 2 plus c1. Now we want the displacement. Okay, how much it moves from its original position. We want that, right? So let us assume that its original position is at the origin. Okay, let's say the origin position is 0 0, because we want the displacement. From wherever it started its journey is not the matter here. We want how much is the displacement. So if we assume, so for the simplicity, if you are assuming it starts from origin, so this will again give us c1 equals 0, because at t equals 0, x equals 0, this implies c1 equals 0. So substituting the value here, we obtain x equal 5t square. This is the thing. Now we want its displacement after 10 seconds. So now if t equal 10, then this gives x equal 5 times 10 square, that is 500. So the displacement is 500 meter. Okay. Two masses m1 and m2 connected by an inextensible string shown in this figure over a frictionless pulley. So there is no friction. Are moving as shown in the figure. It's moving in this direction and it is moving in this direction. And this arrow upward is showing the tension. Okay, and here also this is basically tension. So if we draw the free body diagram of M1, so we have tension in the upward direction and gravitational force in the downward direction, and in this system we have tension, and so according to Newton's law, the force is this, okay, for F1. I am just writing the magnitude, only the scalar part. So the force is this one according to Newton's law, T minus m1g in the upward direction, okay, and for this one we have tension in this direction, and we also have a friction. The pulley is frictionless, but the system with the table, there should be a friction because the coefficient of friction of the horizontal surface is given 0.15. So the horizontal surface, this is not smooth, it has some friction, okay. So it has some frictional force in this direction, and we know that it is mu kn, okay. So what is n? N is in this direction, which is basically m plus m2g, okay. Normal force is equal to the gravitational force, normal reaction, and so in this case the force of the system is T minus m plus m2g in this direction, okay. So we have the force along this direction, I mean along positive x-axis is T minus m plus m2g, and force along this direction, actually I was thinking to write this in the reverse way. I mean F1, we should let me write this m1g minus t, okay, downward direction. So force along this downward direction is m1g minus t, okay. Now we have to find the minimum weight m so that the system remains stable. I mean it does not move, either this one or this one. If this moves, then it will move, right? Similarly, if this remains still, then this will also remain still. So in order that there should not be any motion, so for that what we need is m plus into this thing. Sorry, it will be mu k. Okay, it is T minus mu k, right? T minus mu k, right? Force is basically T minus mu kn along this direction. Now, in order the system as a whole remains stable, this m plus m2g mu 2, this friction force should be greater. This friction force should be greater than the tension, right? Greater than equal to the tension. Otherwise, the string T will capable to push this m plus this system towards this direction, and there will be a motion, right? Did you understand what I am trying to say? If mu k is larger than this tension, then this system will remain still, it will not move because it is then a static friction, right? It is still in the static friction. So if mu k is greater than t, then this system will not move because mu k is greater than t. If mu k is less than t, then it means t is higher, so it will be able to move this system from here. If the friction force is higher, then the system will not move. If the friction force is lower, then the system will move. Okay. So in order the system remains still but move, we need the friction force to be higher than the tension of the string. Okay. And what is T? If the system is not moving, then it means m1g equal T. Okay, because the system is not moving. If this does not move, this will also not move. So m1g equal T. So from here we will substitute the value of T. So we have mu k m plus m2 greater than equal m1. Now substituting the value here, we have given mu k 0.15 m plus m2 is 10 greater than equal m1 is 5. So if we simplify this now, it is just simplification now. This gives m plus 10 greater than equal 5 by 0.15, which is basically 5 times 100 by 15 is equal to 100 by 3. Yeah. So m greater than equal 100 by 3 minus 10 equal 70 by 3. So m should be at least, we want the minimum value, right? Here somewhere it is given the minimum weight. So m should be minimum 70 by 3, which approximates to something, whatever with the approximation. M should be minimum 70 by 3 kg. Okay. The minimum weight of M should be 70 by 3 kg. If you have given multiple choice option, then you may have given 70 by 3, or if it is given in the decimal, then you have to calculate how much it is off. Maybe it is 60, 23 point something. The work done on a particle of mass m by a force. So this is the force. So let's write down the force. It is something like this: x by x square plus y square 3 by 2 I cap plus y by y square plus x square 3 by 2 j cap. Let's pull it out outside. I'm just simplifying, that's all. So this is the force where k is a constant when the particle is taken from from a0 to 0a, right? So let's say this is a comma 0 and this is 0 comma a, and the path is along a circular path. So the particle is taken along this direction in the xy plane. So you have to find the work done in this case. Okay. So observe that since the particle is taken along this circular path, and we have given the force equation is something like this. So we can say that x square plus y square equal a square, right? Because we are on the circular path, and on the circular path x square plus y square equal a square. Okay, in this case, because the radius is given as a, so x square plus y square is constant, so we can write our m vector in this way: k by a cube x I cap plus y j cap. And since xy is on the circular path, so we can think that x equal, converting it into parametric form, x equal a cos theta, y equal a sin theta. Okay, so this will further reduce this. It will be k by a square and it will be cos theta I cap plus sin theta j cap. Did you understand what we did here? See, the path is the circular path, right? And we know the equation of a circular path, center at origin is this. Now we simply substitute this value here. We obtain this thing. And now we are in the circular path. Okay, we are in the circular path because the particle is taken along the circular path. So we can substitute x by a cos theta, y by a sin theta. So 1a will be again cancel out. So instead of a cube, it will be a square. Okay. So right now our equation of force is this. Our force vector is this one. Okay. It is quite simplified version instead of this one. Okay. Now we have to find the work done. Okay. So what is the formula for work done? We know that work done is if a vector dot ds, right? Integral of a vector dot ds. Yeah. So we have here in this case, our path is circular path. We are moving from A0 to 0A. Our F vector is K by A square cos theta. Actually it is a bit it's a bit higher mathematics. It is called line integral. Okay, this is called line integral. So this is a formula for work done actually, and in this case we need to apply this line integral formula. This dot ds, and ds is also a vector actually. So what is our ds? What is our ds? So our ds is basically, we can write this as x I cap plus y j cap. Okay, because at any point, what is the coordinate of at any point of any arbitrary point is x comma y, right? So what is the position vector of this point? X I cap plus y j cap. Did you understand what I am saying? See, the coordinate at any point on this circle, we can consider this as x comma y. And what is the position vector of this? It is xi plus yj cap. So ds is nothing but this thing actually. Okay. So we will simply substitute this value here. Let make this as c instead of writing this as a comma 0 to 0 comma a, because now our variable is theta. So it will be no more as a comma 0 or 0 comma a. It will be according to the value of theta. Okay, because our variable is theta. So I am writing this as c. We will figure out what will be the upper limit and lower limit. So let's finish this part of calculation first. Sin theta j cap. Now observe that what is our x and y, as we mentioned earlier, or since we are lying on the circle, we are working on the circle, so we can simply substitute, replace x by a cos theta and y by a sin theta. So this is basically dot d a cos theta I cap plus a sin theta j cap. We simplify this. 1a will be outside, so it will be k by a integral over this curve over the circle. So we have cos theta I cap plus sin theta j cap dot d of cos theta I cap plus sin theta j cap. Okay, I have very little space here, so let me rewrite this once again. It is basically, let's erase this. It is not understandable. Let's erase this. So basically this is, simplifying, it is k by a square, this curve or this line integral of cos theta I cap plus sin theta j cap dot d of, I will pull out the a because a is constant, so it will be a, k by a. Okay, so this is cos theta I cap plus sin theta j cap. This is k by a line integral cos theta I cap plus sin theta j cap. This will give dot of, I will insert d inside. Inserting d inside, we have minus sin theta I cap plus cos theta j cap d theta. Okay, because differentiation of cosine theta is minus sin and sine of cos. So now if we take the dot product of these two vectors, what we are obtaining is, we are obtaining as cos theta minus sin theta, minus cos theta sin theta plus sin theta cos theta. Yes, formula for dot product. If you don't know the formula for dot product, it is like this: A I cap plus B j cap. Dot product of these two is, let's say we have two vector A I cap plus B j cap and C I cap plus D j cap, and we are taking the dot product of these two vector. The formula is AC plus BD. Okay, we will take this one plus this one. Okay, and dot product is a scalar. Okay, work done is a scalar, right? Dot product is a scalar, so it is AC plus BD. I did the same thing here. See, cos theta minus cos theta sin theta, and then plus sin theta cos theta. See, minus for C it is minus cos theta sin theta minus cos theta sin theta, for this, and for this plus, we have some plus, the symbol is plus sin theta cos theta. So this is basically 0. Yes, this part is 0. So the net work done is 0. Okay, net work done we obtain is 0. If you have any doubt, let me know. But let me recapitulate what we did here. See, we have given this force, right? The expression of this force. I just simplify it in this way. In the first line, I just simplify it in this way. I don't know anything, okay? Now, next I get to learn is the other condition, that we are on the circular path. Wow, we are so lucky. We are on the circular path. Since we are on the circular path and the circle is about the origin, so the center of the circle is origin. So we substitute x square plus y square equal a square. We substitute x square plus y square by a square, because this is the equation of a circle. And since we are on a circular path, so we can simply substitute x square plus y square will be constant, right? Because it is the equation of a circle. So x square plus y square equal a square, we simply substitute this value here, and it reduced to this. But we reduce further actually. Since we are on the circular path, we again apply this condition. The parametric form of a circle is this one. Okay, center, a circle whose center is at the origin. Its parametric form is this: x equal a cos theta, y equal a sin theta. Since xy is on the circular path, so we substitute this value x equal, we convert this into a parametric form. We convert this Cartesian form into a parametric form because we are in a circular path. Otherwise, it wouldn't have been possible. Okay, since we are in the circular path, all these things are possible. So we have a k by, we just substitute and simplify and we apply this. So this is more, this is a further reduction of this expression into this. Now let's come to the definition of work done. What is work done? Work done is defined by this line integral. In this case, we need this formula. This f dot ds integral of c along the path. Okay, f dot ds we know. The new thing is this integral formula. If you are already familiar with this integral, then it is still better for you. But if you don't know, work done can be defined as a line integral. Okay, work done is defined as a line integral where along the curve, what is the curve is given. So in this case, the curve is given circle. So the line integral along this circle and f dot ds. This we know from the junior class that f dot displacement is the work done. So the total work done for the particle, to take the particle from this point to this point along this circular path can be obtained from this line integral. Total work done to take the particle from this point to this point along the circular path, can be obtained from this line integral formula. Now substitute the value of f. We evaluate ds, our ds. How ds can be evaluated? Where is our s? S is on this path, on the circular path, and any point on this circular path, how it looks, it is xy. Any point on a circular path is xy. And what is xy? coming back again here, x equal a cos theta, y equal a sin theta. Okay, so this is the point form, but since we are doing line integral, we have some vector here, so we need to convert s into a vector form as well, because ultimately s is a vector, s is displacement, right? We cannot write in point form. We need to convert this into a vector. Okay, so we convert this into a vector xi cap, which is position vector xi cap plus yj cap. If you are already familiar with the vector, you know, right, that any point on a Cartesian coordinate on any point xy can be write in this way. The vector form of this point is xi, it is called position vector. Okay, let's say this is O, this is P. So coordinate of P is xy and the position vector of OP is xi plus yj cap. So we convert this s into a position vector xi cap plus yj cap, substitute the value of x and y because we are on a circular path, a cos theta plus a sin theta. Next we simplify this, pull out a outside because a is constant, right? D of AC, D of AX, what is this? It is ADX because a is constant, yes. Now one a got cancelled out. Now we have this thing. So we insert d inside d cos theta I cap. It is like this actually. It is d. It is d cos theta I cap plus d sin theta j cap. This looks exactly like this. Now what is d cos theta? D cos theta is minus sin theta d theta, and what is d sin theta? It is cos theta d theta. So now we obtain this after doing the differentiation. Then we apply the dot product. Formula for dot product as given here: a I cap plus bj cap dot c I cap plus dj cap is defined in this way: ac plus bd. It is the formula for dot product. Okay. So simply apply the formula for dot product, simplify it, we obtain the answer is 0. Okay, so total work done is 0. A metal wire of uniform mass density having length L and mass M is bent to form a semicircular arc. So this is a semicircular arc. Okay. Let's name this as A, let's name this point as B. So its mass is M, its length is L. So the whole length is L. Okay. Now what happened is a particle, its mass is M, its length is L, and a particle of mass M is placed at the center of the arc. Let's say this is the center O, particle M is placed here, and we have to determine the gravitational force on the particle by the wire. Okay, so let's first do one thing. Definitely we need to apply calculus here, because what we will be doing is we will take a small mass. Let's take a small mass. Let's take a very small part from here. Why we need calculus? Because what is our idea is we will take a very small part, a very small segment, infinite small, and we will compute the gravitational force of that small segment towards this end. Do you understand what I am saying? I am taking a very small length here, infinite small. Okay. Then we will compute the gravitational force of this, gravitational force due to this small segment upon this M. Okay. So let's say if the length of that small segment, considering this as ds, okay, is ds. So what is the mass of this small segment? It is, since it is uniform mass density, so it is basically m by l, right? The mass of this small segment dm is m by l ds, and what is the gravitational force because of this, due to the small mass upon m, is m dm by s square. Yes, this is the gravitational force. Basically, this is the magnitude of the gravitational force. Okay, this is the magnitude of the gravitational force. And what is a? A is the radius. This is different color. A is the radius. Okay. Since circumference is pi a, so pi a equal n, from here we can obtain a equal n by pi. But I will come to this part later. So this is the magnitude of the, let's do one thing, let's make it capital N, okay, that is too confusing because we have too small n here. So the mass of the small segment is dm, and the gravitational force, sorry, that will be g, gravitational constant. So the gravitational, I mean the magnitude of the gravitational force is this. This is a magnitude, but it's a force. We cannot stick to magnitude, we need the direction also. Okay? So what is the direction? Let's say I am taking this is the direction. So if this is theta, then it will be theta plus d theta. Okay, I think it is not understandable. Let's write in this. It will be theta plus d theta. Yes. So the, what is the direction? We need some direction, okay, along this. So it will be some unit vector. How we obtain the direction? Let's say p is a vector. Okay, so how we write? We write the magnitude of p vector times a unit vector along p, along p vector. So we need some unit vector along this direction. Did you understand? We need some unit, because force is let's say this is let's name this as OP. Okay, so the force is along OP direction. So we need some unit vector along OP direction. We have the magnitude. We have the magnitude of the force. It is given from Newton's gravitational law. But we need a unit vector along OP direction. Let's name this as OP cap. So what is OP cap? So if we consider P, since this is a circular wire, so again we can consider P, the coordinate of P as a cos theta, a sin theta, and therefore the position vector OP will be a cos theta I cap plus a sin theta j cap. But we need unit vector, so since it is OP cap, so there will be no a here. Okay, so this is gm dm by a square cos theta I cap plus sin theta j cap. This gives the gravitational force vector. Okay, this is a vector actually. If we don't have this term, it is the magnitude. If we are not having this term, then it is only magnitude. This one is only magnitude. But force is a vector. We cannot write it freely unless we know the direction is along x-axis, unless we know the direction is along y-axis. But here at every point the direction will get changed. So at every point the force will get changed, right? So we need to substitute we need to mention the direction, because direction will get changed. See, our direction is variable because theta is variable. Okay, so if the direction is fixed, then there is no need to mention the direction. But if direction is changing at every point, then you need to mention the direction. Otherwise, our calculation will be wrong. So this is our f vector. Now we are going to integrate this. So let's say this is df, okay, because we have taken this small segment. Till now we are confined in this small segment actually, okay. So if we integrate, then we will get the total force. Let's say this is f vector g m by square cos theta I cap plus sin theta j cap by dm, okay. Now what is our dm? Dm is m by l, and we know ds is a d theta, right? Yeah, s equal r theta, so ds will be a d theta, okay. So we'll substitute this value here. We will pull out the constant, whatever is the constant, cos theta I cap plus sin theta. Let's mention this as c because we are on the circular wire. It will be m by l a d theta. I think it's simply untidy now. So let me increase the space here. So this is basically I made a mistake here, which is G small m, a capital M, A square L, C cos theta I cap plus sin theta j cap d theta, okay. So if we simplify this a will get cancelled out. This is basically gmm by al, and then integral of, now see, theta is varying from 0 to pi, right? Theta is here, theta is 0, and here theta is pi. So this is basically from 0 to pi and whatever is there. So we have gmm by a. Now observe that this is basically 0 to pi cos theta I cap. Let's pull out I cap also outside. Cos theta d theta plus 0 to pi sin theta d theta. Now see, if we integrate cos theta, integrating cos theta gives sin theta, right? So sin pi is 0 and sin 0 is 0, so this term will be 0. So left only this term, so this is basically gmm by al. And what is the integral of sin theta? Integral of sin theta is minus cos theta, right? So I think I need some more space on the right hand side. So this is basically, we have j cap minus cos theta 0 to pi, okay, because integral of sin theta is minus cos theta. gmm, and the direction is along j cap, so I will write j cap here. Now if we simplify this, this is basically minus of cos pi and minus and minus minus plus of cos 0, okay. Yeah, so this is basically 2gmm by al j cap. Now depending upon the answer, if in the answer it is, I mean the direction was mentioned, then you need to mention this j cap. If the answer only magnitude is mentioned, then you need to mention only this term, okay? Only this one. But the thing is, we do not have A given in the question, I think. So we need to evaluate A as well, and A will be evaluated from this part. So this is basically 2gm capital M, or now L is L by pi, so this is L square pi, okay? So the gravitational force Fg, I mean the magnitude of the gravitational force is this. Its direction is around y-axis, okay? So let me repeat this once again what I did here. So first what I did is I take a very small segment from this circular wire, okay? I name it as ds, a very small element, ds. I assume this mass of the small segment is dm. So what will be the mass? The formula will be, since it is uniform mass density, because the mass density is uniform, only then it can be written in this way, otherwise it cannot. If the mass density is not uniform, then you cannot write this as n by n. Basically n by n is the density, okay? So the mass of this ds segment is m by l ds. And what is our ds? I will come to that later. So this is our dm, the mass of that small segment ds. Now what will be our f vector? I mean, what will be the gravitational force of this? Now we are considering of only this small element, okay? And we have a m here, particle of mass m. So if we consider, forget everything. If we consider only this small element, then the gravitational force, I mean the contribution of the gravitational force, only this small element, because of this small element will be this thing. Yeah? OP is the unit vector. Now we need to evaluate OP because OP is variable. And P is also a variable point, and we know that any variable point on a circular path can be written in this way. In the position vector format, it is this one. Yes. So we substitute the position vector format here because OP cap, so A will not present. We need only the rest part, which is a unit vector. If you take the modulus of this, you will see it is a unit vector. Okay. So we obtain Gm dm by s square, substituting the unit vector formula, substituting OP cap, the value of OP cap in this way. So this is the gravitational force due to the small element upon this particle m. Okay, did you understand? Did you understand this OP cap part? P vector is a cos theta a sin theta. In the position vector format is a cos theta I cap plus a sin theta j cap. But we need OP cap, not OP vector. We need OP cap. OP cap is a unit vector. So we need to eliminate A, because if it is A, then it cannot be a unit vector. Eliminating A, we are getting the unit vector cos theta I cap plus sin theta j cap. That we substitute. So OP cap is this unit vector. Now we integrate both sides along this curve. Now we integrate. It is this one, and then we substitute the value of dm. From here we know ds, from this relation s equal r theta, ds equal a d theta, because it is very small part, it's a very small, infinite small arc. So ds equal a d theta. Yes, so we substitute the value of ds as a d theta, convert everything into theta variable. Whatever left constant, we pull those outside of the integral, this whole part, and inside we have this variable thing, and we are evaluating this integral over this curve. Now the time has come to substitute the lower limit and upper limit. Since we are on the curve and we are evaluating with respect to theta, so we will consider the variable and the lower limit and upper limit upon depending on the value of theta. From where theta is starting from 0, and where theta is ending at pi. Yes, here theta is 0 and here theta is pi. Yeah, so theta from 0 to pi, substitute the value from the integral, you obtain the result. Yes, if you still have any doubt, let me know in the comment section. Okay, for a periodic motion represented by the equation this, the amplitude of the motion. So we know that sine omega t plus cosine omega t. First of all, the thing is, we know that if the expression is, it can be written in this way, sine kt plus c, then a is the amplitude, right? Yes, a is the amplitude. Now in this case we have the equation y equals sine omega t plus cos omega t, and we know that this can be written as in this way. This is basically sine omega t cos pi by 4 plus cos omega t sine pi by 4. This is root over 2 sine of omega t plus pi by 4. Okay. So according to this one, this is the amplitude. Yes. So the amplitude of this periodic motion is root 2. Yes. If the acceleration due to gravity experienced by a point mass at height h above the earth's surface, let's say this one, this is h, let's say we have the particle here, point mass, let's say p, and this is okay, this is the center, as that of the acceleration due to gravity at a depth xh. I see. So let's say, let's make it different color. This is xh. Let's mention this as p dash. So I have to find the value of x. So what is the thing is, the gravitational, the acceleration at p and the acceleration at p dash are equal. Okay. So acceleration at p equal acceleration at p dash, because they are same. Yes. So now what is the acceleration at p? It is the straight cut formula. This is basically 1 minus h by r, right? And acceleration at p dash is 1 minus depth is xh, so it is xh, sorry, it will be 2h by, yeah. The formula is, when as height and the height is at p, when the height is above the earth's surface, and the altitude, height is h above the earth's surface, so gravitational acceleration is 1 minus 2h by r. So if we now simplify this, we obtain 2h by r equal xh by r, and this gives our x equal to, so the value of x is 2. Okay. Yes, I just simply apply the formula here. What is the gravitational acceleration at p? It is 1 minus 2h by r. What is the gravitational acceleration at xh depth? It is 1 minus xh by r. So I just simply equate this, and from here we obtain x equal to, yes, it is straight cut formula actually. Okay.